Have you done create and display of the single linked list? Everyone. If you replies, what about others? Have you started implementing? If not, you have to start it today because until and unless you implement it by your own, all the functions, you will not understand the linked list operations properly and you will not be able to perform by your own. It's required, as I told in the lecture also, linked lists are always required for the advanced data structures. Okay. Uh, Rudra, create function is nothing but calling insert int function multiple times. Have you understood that insert int operation? Inserting a node at the end or no? Yes. So in the create function, we have done only that. We have called accept and accept for memory allocation, then accepting the data and initializing the next pointer to none. That is done in accept. And then we have inserted the node at the end, and that insertion at the end logic, it is called multiple times in the while. So even if you don't have that create function separately, it is okay. You can call insert functions, okay, different insert functions to enhance your linked list. Okay. And in the morning, we have discussed about the searching, modify, deletion, or deletion at the given place, then insertion in between all those operations. Okay, so this is the accept function in create. Whatever is this function, this is nothing but insertion at the end logic, which is called in the loop. This is the do while loop in which we are calling this. Okay. Then traversal function, then insertion at given position. So here we are accepting the position from the user, and see there are two ways in insertion. In case of insertion in between, one case is if you are taking the location, that is at third location I want to insert or at fourth location I want to insert, like that. So this is one logic. So suppose if I say here at third position I want to insert this node, so I will have a counter and I will stop at second uh, node, so that after that I can insert the node. Okay, so when I is less than location minus 1, I will go till that place, and after that particular node I will insert the current node. Okay, so this is the insertion. Okay. So P is the node which is to be inserted, and Q is the position of the node after which we are inserting the node. Okay, so I think all of you can do these operations uh, by your own also. Any doubt in this? No need of explaining each and every step here. Okay, insertion in between hai, so this is same. We are first accepting that new node which is to be inserted. Then I is 1 and I will be the counter, which is initially 1 when when Q is pointing to header, and then Q will be advanced, Q equal to Q next until we reach to the required location. Okay. So this loop will take us to the required location, and after that we can insert P. So after Q next, P will be inserted. Okay. So we have seen diagrammatically how these operations are performed. Then another way is if the data is given, that instead of the position, if data is given, like after 31, insert this particular node. So we will be having the search operation, the logic like search operation where we will be comparing the data, and if we get that required data, after that we will be inserting. Okay, so instead of the position, we might get the data after which we want to insert the new node. Okay. So searching will be same way. Instead of location, what you will be doing, you will be comparing the data with the required one, and when we get that data, so this while loop, it will go on comparing the data and accessing the nodes. Okay, and we will stop at the required location, and after that required location, the insertion will be in the same way. Okay, this is insertion in between. Then delete begin, we have discussed already. Delete begin, where we have to first modify the header. Okay, before modifying header, we are taking the reference of that header in a temporary variable a, temporary node a, then first equal to first next, and a next is equal to null. Okay, so before we free a, we are saying a next is equal to null, and then we are reallocating the memory. Similarly, in delete end, here we need to search for the last node, and at the same time we should have the reference of the previous node. Okay, today in the lecture also we have seen why two pointers are required, previous and current. So a is our current and b is the previous node. So with this loop we are moving to the last node in the linked list, and that is the node which we have to delete. So a is the node which is to be deleted, and b is the node which is previous to it. Okay, so b next will be now equal to null, because b next is a at this moment, and we have to remove a. So we will modify the link b next equal to null. So second last node, it will be now null, and then we can say free a. Okay. Then delete position, here also you need to reach to the required node. So we are taking the uh, key from the user, and we are searching that key. Okay, we are starting with the header a equal to first, so we are using the walking pointer, and we are advancing till we get that particular node, or if we reach to null. Okay, so here there should be one more condition. E should not be equal to null. Okay. And if we get to that condition, if A is equal to null, then we should say record not found. Return from. Any doubt here? So here in deletion, we are setting the pointer. B is the previous node and A is the current node which is to be deleted, because here we are comparing the P with the A data. And if we reach to the null node, then record is not found, which is to be deleted. Otherwise, A is, this loop has stopped because we have reached the required node. And then this is the previous node. So previous node's next pointer will be now moved to A next. That is current node's next pointer, because we have to delete A. Okay, so pointer of this previous node will be modified. Okay, previous node, it will not point A, it will point to the A next node. Okay, and before we say free A, we will in next equal to null, and then free A. And searching is linear search. Modify, here also location is taken. You can take the data also, the key also, and accordingly you can search. And the details will be modified for that particular record. Are all these insertion, deletion, and modification searching functions clear for single linked list? What is the doubt, Google? Basically, we have used do while loop in create function. Yes, Brutal. In create, we are using insert time logic multiple times. You can use any logic. Insert begin logic also you can use in creation of linked list, or even if you don't have that separate function, it is okay. You can create the linked list by using insert operations. I will share entire screen and I will execute the program. What is it? One parameters we are having. So I will not call create. I will create the linked list with insert function only. Insert begin. But in insert we should have that condition, no? That if it is the first node, I will check whether we have that condition in every insert function. No, because this condition must be there in every insert function. Then if first is null, then first is equal to new node. Then only that logic will work. node which we have to insert is E. So next is equal to B. First is none. First is equal to C. Otherwise, we will do the insert operation. Insert begin. Insert position हो गया, insert end हो गया, insert begin. Here also we will have that condition. A is the node which we want to insert in this. Now I'll execute. So instead of using create, I will be directly saying insert begin. ABC. Employee ID 233. I will insert one more. Okay, we'll do the display. So one node is there in the linked list. One more operation. I will do now insert end. Five. Apartment ID 455. Salary. Now I'll display. So insert end operation. It is also working. Next operation will be insert position. So I will say location 2. I want to enter the node at location 2. And the name of the employee. ID. Salary. So XYZ is inserted at location 2. Okay. Here I'm working on the database, employee database, but you can work on simple integer data as well. Okay. I'm working with database, that's why I'm displaying all the details of employee. But you can have single integer data also, okay, and work on all these operations. Any other operation you want to see? I will insert one more time. Insert beginning one more time. Display. This one more record is inserted in the. All the insertions are clear. Uh, is there any problem in the voice? Okay. Then delete operation. We'll check whether all the deletes are working properly or not. Delete end. I will do first delete end. Okay. So last is PQR node that will get deleted. Now I will display again. Yes, it is deleted. Then I will say delete beginning or delete in between first. I will do delete at given position. So 9. Suppose oh, pressed 9 here. Let's see why. Okay, we will execute it again. Now I will use create to create the linked list. Here there is a loop, so it will run until I say no. One more record I will insert. Display. Create is working properly. And we are using insert end. That's why one by one the records are getting inserted one after another. Now I will check delete position operation and employee ID. It is asking the employee ID of the record to be deleted. 78. Okay. So it is displaying complete record, and now I will check. Yes, it is deleted. Record with 78 employee ID is deleted. So delete is working, and I will now say delete beginning. 7 is also working. Display. Only one record is remaining. Then we can have modify function employee ID of the record to be modified 67. New name department. Actually, it should not ask for the new employee ID. So that is the primary key that you will understand in the database. This is the updated record. Okay, so we have seen here all the insertions, all deletions, search and modify. Okay, the functions which are remaining are reverse and display reverse. So shall we discuss those? Shall we discuss those functions, two remaining functions also today? Or you will perform these operations and then we should discuss? Yes. And uh, tomorrow, in the next lecture, I will be starting with the doubly linked list. Okay, and I want that doubly linked list you should implement by your own. Okay, after we know the logic. So that's why I'm utilizing more turns for single linked list, because doubly linked list it can be performed by your own. Okay, and the doubly linked list is also database operations, but there will be two links which you have to maintain every time when you are inserting or deleting the nodes. Okay, so you will perform these operations first. Request transpose function. Mridul, all the recordings are available. Okay,
Ma'am, I checked them, but my program is giving me some error at the same place again and again.
then you share your program. I will see what is the problem. Okay, because all the recordings are there, so no need of repeating everything again.